so how's everybody doing? Pretty good stuff today.
Performance in chapter today. I have a performance in chapter today.
Oh, you do?
Yeah.
Oh, okay. You prepared? You ready? All right. Anything new? Anybody care to share? Jobs, life. College still worth it? It's worth it? All right, sensation and perception, chapter 6. We touched on it a little bit on Wednesday. What's the difference? What's the difference between perception and sensation? What's the difference? No need for textbook answers, just regular answers. Yes. Yeah, exactly, right? Sensation is dealing with the senses, your sense organs, taking in information from the outside environment. Perception is how you make meaning, interpretation of that. Now, we all perceive differently, which means that we all be looking at the same exact object, and we all will interpret it to be a different thing. Anyone ever seen a Rorschach test? Little ink blots? Right? We use those in therapy sometime to see what do people think they see, right? How do they interpret something that they see? And some people are very literal, like if it looks like a butterfly, then it's that butterfly. Some people are very, very abstract. They'll be extremely detailed about certain things that they think they see. So we all interpret information differently. But we all do it on the common way. We all have the same mechanisms by which we do it, right? That makes life a little bit common and also distinct as well, too. So they're both actually part of one continuous process. You know, it happens they happen together, right? I guess one happens first, the next comes in sequence after the other, but there's really no gap in this one. They happen all together. What we say is sensation is more bottom-up processing, right? Since an analysis begins at the early level with information flowing through receptors, and then up to the brain, and then top-down would be, okay, how do we deduce what we just took in, what we just touched, what we just tasted, what we just saw? How we deduce this to make meaning? And most of that meaning comes from pre-existing information, right? You can't make meaning of anything unless you have some sort of reference. You need a frame of reference. So the things that you've learned previously will dictate what you're going to learn in the present and in the future. All right, so all of our senses, we receive sensory stimulation, often using specialized receptor cells. They're everywhere. They're in our eyes, in our ears, in our nostrils. We have them on our fingers, our hands, our feet, our skin. We transform that stimulation into neural impulses, so we shoot them up to the brain. We deliver that energy up there to convert it. And then after the conversion, we transform the stimulus into things that we can interpret, right? So in essence, we're transforming energy to something meaningful, right? Light is energy, heat is energy, right? Everything contains energy. Food is energy. So those receptor cells can transform energy stimulating energy. So we said we have a threshold. We have a threshold in all of our senses to know how to understand differences between things. Typically, your threshold would be measured at anything above 50%. You could perceive something different more than 50% of the time, and you say we can measure your threshold, right? Which could be threshold for taste between sour, sweet, threshold for light intensity between too bright, not too bright, or different brightness, right? Difference in sound, high, low pitch, all of that, right? Converted. All right, we got signal detection theory, which is what we just talked about with dealing with thresholds, predicts how and when we will detect faint stimulus, signal amidst background stimulation. So obviously if you're looking out into the world, there's constant things happening, and you may have to focus and fix on one particular thing, even though there's things in the background happening, right? So we're able to detect particular signals, differentiate so that we're able to focus on particular things that we want to focus on and we see. We say we have absolute threshold. Example would be can see a far light away in the dark or feel the slightest touch. We all have different thresholds, so some people might be able to sense a certain touch versus others. Or they may not be able to see a faraway light in the dark, depending on eyesight, vision, things of that nature, receptor cells. All right, so your difference threshold increases with stimulus size. So for example, here they're using a 5 decibel increase in volume will be noticed at a starting point of 40 decibels, but not at 110 decibels. And these are experienced as just a noticeable difference. Like, where do you notice that something just is slightly different? All right, now we got subliminal persuasion. Subliminal stimuli are those that are too weak to detect 50% of the time. They are below the absolute threshold, right? So it'd be anything that we can't detect more than half of the time. And subliminal persuasion may produce a fleeting and subtle but not powerful or enduring effect on behavior. Which means that it really may not affect your behavior whatsoever. You can't perceive things to be different below your threshold. Now we're built for adaptation, of course, through evolution. So we have sensory adaptation is diminished sensitivity as a consequence of constant stimulation, which means if something happens over and over and over again, right, constantly, our sensitivity to it will diminish. All right, so you could call it maybe desensitization. That could be for anything. That could be light, sound, right? If you get in the car with someone and they're driving and they're blasting the music, you're like, why you play the music so loud? And I'm like, it's not that loud. I guess it is. Right? You've just been introduced to that loud music. They've already been used to the loud music. It's been constant. Right? So now their thresholds have changed. It's adapted, basically. Right? It's adapted to, and it goes to show you we adapt to anything. So the more consistent something is, the more we will adapt to it, right? Just naturally adapt to it. On a side note, that works kind of overall for your environment. You know, I used to do research, I don't know if I tell you, I used to do research on the Mexican drug cartels, right? basically to study how the people become desensitized to hyper-violence. Not your normal violence, right? I should probably say normal. You read another story about shootings, carjackings in Chicago, and you're like, oh, okay, right? But in other places of the world, let's say from Mexico, you're like, well, it's hyper-violence, right? Using grotesque, brutal ways. You chop body pieces up into 30, put them in a garbage bag, video record, right? Just to scare people, to create fear. But you say over time that people don't leave. They don't leave the city. They don't leave the state, right? They stay. Anybody, oh my gosh, you stay? Like, I could barely deal with the carjackings and the shootings in Chicago. How could you stay with this? People become desensitized. We adapt, no matter how bad it is, right? Shocking to you may not be shocking to them. You haven't had consistent experience of it. But this happens all over the world for whatever happens. You know, if you talk to people during Nazi Germany, you say, how could you do what you did? And they just say, I was just doing my job. That's it. The answer would be, I was just doing my job. This is just how it is here. So once again, what's new to you may not be new to others. But this is the miraculous part of our body, of our brain, our mind, everything. We adapt. Nature will, in essence, force you to adapt, whether you like it or not. But here we're just talking about sensory adaptation, right? Diminished sensitivity as a consequence of constant stimulation, right? It aids focus by reducing background chatter. The more you observe something, the less the background noise affects you, right? Anything happening in the background. Influences how the world is perceived in a personally useful way. We like consistency, right? Even think beyond the senses. As a whole, we have a relationship. We don't bond with people unless they're consistent, right? Maybe the argument people have against other people in relationships are like, oh, you're too inconsistent. Therefore, I can't really latch on it, right? Because it has to be more meaningful, consistency. Our sensory receptors are sensitive to novelty, right? To new things. Sensory adaptation even influences how we perceive emotions. Which, you know, if you're exposed to something a lot, your emotions will change on how you feel about that thing. For example, right? Let's say you haven't been used to the new car, right? And then you have this desire to get this particular car. Like, I gotta get it. But like, if I get it, I'm gonna feel great, right? You desire it. And you get the new car. Let's say it's an awesome car, whatever it is. It's a Lamborghini, it's a Ferrari, it's Mercedes-Benz, it's whatever it is. Whatever you desire, right? Your original perception, because you haven't experienced it yet, is that you will feel a certain way, and that certain way will probably be constant. You get the car, now you get used to it, you drive around, and after 2 months, you feel less about it. It starts to become just a car. And you have to say like, oh, I gotta maintain it. And other people are like wowed by it, like, wow, you got this. And you're like, yeah, I got this. You get what I'm saying? So what's new to people presents a stimulus. Wow, right? If you've had it a long time, it doesn't matter to you anymore, right? You're used to it. And that goes for anything. Like as a person who's, I guess, been able to like travel and buy cool stuff, you realize all that stuff will wear off after time. And then you learn about things wear off. So don't give it too much impulse or desire. That's wisdom, I guess. Just learning through experience. Don't give anything too much desire because it will wear off. here it is giving an illustration of emotion adaptation, right? We just changed from this state of saying maybe a bit angered, right? Maybe less anger to just a bit surprised. Let's say that you're in an argument with a romantic lover or some case, and they send you some information that's new, right? Maybe they cheated, right? Maybe your first initial response through the conversation, at the beginning of the conversation, is anger. Right? Or, let's say at the beginning of the conversation, it's this one. Like you're shocked. You can't believe it. This is new information. You're processing it. And then you bounce on from maybe a sense of curiosity, because your brain has to interpret, right? So it's come through your senses. It's come through talking to them, through your eyes, through your mouth. You're hearing the information. So you go from shocked and maybe here to where confused, because now your brain is processing top down. You're perceiving the information. And now you come to a new conclusion at the end, right? I'm angry, I'm triggered. So we could quickly adapt based on whatever the information is we receive. All right, so we all have perceptual sets, mental tendencies and assumptions that affect top down, what we hear, taste, feel, and see. We all have these assumptions about things based on previous experience or knowledge or information about those things. So we all come with our assumptions, which means we all have inherent bias, right? We may have some sort of bias about everything because of our assumptions. We need more information about the thing to come to some sort of truth about it. So perceptual set would be those tendencies to assume about things based on what we've heard previously. Right? So schemas, organize and interpret. We talked about schemas, which is basically the brain's way of organizing and interpreting information through your experience. And then your pre-existing schemas, like how you previously organized and interpreted things similar to what you're either seeing or hearing or talking about or trying to interpret. And here they say including gender stereotypes, but this includes any sort of bias about something based on pre-existing experience and knowledge. So we tend to generalize on a lot of things until I guess we're kind of proven different. We need new experiences to prove us differently. Any questions so far? All right, things are context dependent, right? Context dependent. Given stimulus may trigger different perceptions because of immediate context. Right? Let's say, what's the story behind what we're seeing, hearing? Perceptions are also influenced by our motivation and emotions, right? Walking destinations look farther away when we are fatigued. You ever go on a long hike or you gotta walk somewhere far, the more tired you get, the more further something seems like it is, right? It seems like you'll never ever get there. If you ever taken a road trip, particularly towards like the end of the road trip, or coming home, right? The journey back home seems really, really longer than going there, because you were motivated to go. You're excited to go to the place. But coming home after everything is done, you may not be so happy to come home, because you just experienced all this motivation from getting to the place. Slopes seem steeper when we are wearing a heavy backpack or after listening to sad, heavy classical music. Or water bottles look closer when we are thirsty, right? So depending on our drive, things may seem closer to us than they actually are. Emotions and motives also influence our social perception. So we have these cognitive biases, which we say, man, I want to believe that things are this way. I believe things are this way. Why do you believe things are this way? Because really you're motivated to believe things are that way. When you come to find out that things aren't that way, you may still struggle and say, I can't believe things are not this way. They're not as they seem for this particular thing. All right, so we have those cognitive biases. We want things to be this way based on how we were raised or what our motives are. And so in life, one of the greatest challenges I would say in life is acceptance. Like asking yourself, okay, if things don't happen the way I thought they should happen, how much anxiety or stress or anger will I have, right? College doesn't work out the way I think it will work out, or thought it would work out. You know, how destroyed will I feel? How much will that impact my life? Will I be able to move on? Will I accept it? Like anything. If someone breaks up with you, right? What is your ability to move on and accept the fact? All right, we'll get into light energy in eye structures, right? So our eye is human beings are mostly visual over any other sense, over touch, over taste, over sound. We're primarily visual because our initial impressions of things typically come from sight. Right? Even when we hear music, we still visualize the mental concepts of what the music is saying to us. Right? We create stories in our mind about what the music is trying to say. So wavelength, distance from the peak of one light wave or sound wave to the peak of the next, that's right, wavelengths come in frequencies. You have the length of the wavelength, you have how high it is, the amplitude of it, and this will primarily dictate on the intensity of which we see things, right? The detail of which we see things. Think of the sun. Sun is white light. If you don't perceive it as white, you perceive it as orange or yellow because it goes through, the light scatters through the atmosphere, and we pick it up through those wavelengths, and we create different visual perception of it. So the intensity, right, amount of energy in a light wave or sound wave, which influences what we perceive as brightness or loudness, right? And hue, dimension of color that is determined by the wavelength of light, which we know as color names blue, green, and so forth. We'll talk about rods and cones, but we primarily in our eye have red, green, and blue perceptors, and from all of that we can make other colors, right? We can determine a lot of other colors just based on that. All right, what is seen as light is only a thin slice of the broad spectrum of electromagnetic energy, right? Photons, light is electromagnetic energy. We as human beings can only see on a certain spectrum of that, which we will call visible light. Right? This invisible light, coming from gamma rays, X-rays, the sun exudes all of this, yet we don't see that stuff. We only see what we would call visible light. But as a portion visible to humans extend from the shorter waves of blue, violet light to the longer waves of red light. Or other organisms are sensitive to different portions of the spectrum. Bees, for instance, cannot see what we perceive as red, but can see ultraviolet light, right? So different animals and species of organisms see different things that we see, right? Primarily we say dogs are kind of colorblind, right? The dogs don't see color the way we see. But they have that for their own reasons, for their survival. The perceived hue in the light depends on its wavelength, and its brightness depends on its intensity. Everything comes through a prism in our visible spectrum. All right, so white light comes in from the sun, let's just say. Goes to the prism of our eyes, scatters, and create, here we say red, green, and blue. And from here we can create thousands of colors based on that. But here's the part of the spectrum visible to human beings only. Here's the total spectrum of light. Say gamma rays, X-rays, ultraviolet rays, infrared, radar, broadcast bands. We don't see any of this, but it exists. Right? Even the sun now goes through walls, right? The energy passes through the walls of a building. So it's constant. It's passing through these walls right now. You have no idea because you don't see it. You're not able to perceive it. All right, short wavelengths are high frequency equal bluish colors. Long wavelength, low frequencies equal reddish colors. And here's the amplitude we talked about, which is really the height of these waves. Those are for bright colors, intense colors. The small amplitude creates dull colors. It all depends on the wave type, the properties of the wave. All right, in your eye, your cornea, the portion of the eye through which light passes to the pupil and lens and is bent to help provide focus. We have our pupil, the small adjustable opening through which the light then passes. You have your iris, colored muscle surrounding the pupil that controls the size. So the iris is your colored part of your eye. And we all have different colored eyes, but we all have brown filaments in them. Even if they're red, even if your eyes are green, blue, gray, anything of the sort. You look really closely, you still have little brown filaments. And so that iris controls the pupil, right? And it makes it small. And that's why if you're on drugs, if you're on cocaine, you have dilated pupils, right? It opens up and allows a lot of information, maybe too much information to where you can't see anymore. So you're stumbling as you walk, you can't drive. This happens too when you drink alcohol. You can't see as clearly as you could in a normal setting. And your lens focuses incoming light and rays onto an image on the retina, on the eyeball's sensitive inner surface. So the thing with a lens is just like a camera lens. It's just for focusing the light to produce an image. All right, your retina contains two types of receptors, rods and cones. They have layers of neurons that begin the processing of visual information. The rods and cones are for different things. Cones are particularly for color and sharpness. Right? The rods are for dullness and non-colored aspects of light, right? To distinguish between like grays and really dull colors. Any accommodation is the process by which the eye's lenses change shape to focus near or far objects on the retina, which we describe almost like your camera on your phone. It's just for zooming. Now you have receptor cells all over your eyes, and they're there even though your lens and your pupil are at the front. You still can see things off to the side. So if something comes way over here, you're like, well, I'm looking over here. How did I know this? You have receptor cells all the way through, so you're able to pick up things faintly off even over here when you see things off to the side. Here you have your pupil, you have your lens right behind the pupil, right? You have your cornea, which is this outer layer. You got your retina, which is all of this part of the eye. And it all goes here to be processed through the optic nerve and sensitive brain's visual cortex. And you do have a blind spot in the eye, which means you can only take your eye so far to see things. And that blind spot is really located way in the back. Eye-brain pathway. So your light energy particles trigger chemical reactions in receptor cells, rods and cones that form an outer layer of cells on the retina at the back of the eye. We say rods are looking for, detect black, white, and gray, sensitive to movement. So rods are responsible for looking at things that move and necessary for peripheral and twilight vision. So rods are for really night vision. You can't pick up too many colors in the dark. That's why your cones don't really work that much in the dark, because you can't pick up, but you need your rods to be really good. And cones function in daylight or well-lit conditions and detect fine detail and color. Here they're giving examples of what the rods and cones look like, but in honestly, they kind of look both the same. It's just that the rods are a little bit more narrow looking. The cones are a little bit more bulbous. So here, light entering the eye triggers chemical reactions in rods and cones at the back of the retina. Right? We'll use them for these bipolar cells and ganglion cells. The chemical reaction in turn activates those cells. And then it goes to the visual cortex via the thalamus to make sense and interpret the information of what you're seeing. So you have about 6 million cones in your eye, right? In the back of your eye. You got about 120 million rods, which means that we can see a lot of color, even though we only have that small visual spectrum of light between the veins. We have less cones because we may not necessarily, we need more information during the daytime. We use way more information in our eye during the day to pick up a lot of the activities that we do. So it makes sense a lot of colors and things like that during when light is out. And then the optic nerve carries neural impulses from the eye to the brain. That's that large nerve we just saw in the back of the eye. And then that blind spot, the point at which the optic nerve leaves the eye, where no receptor cells are located. And then we have the fovea, which is the central focal point in the retina around which the eye's cones cluster, and that's for focus. Now here's our visual cortex. Here's the visual area of the thalamus and brain. So we see we have your eye's right here, and there's a cross section here, right? Particularly a lot of things in the brain cross. Why do you think things cross in the brain? Saying here, for example, this optic nerve. Why did nature give us these sort of crossing pathways? Why do things on the right go to the left? Things on the left go to the right? Right? It's sort of a backup system. In case something bad happens, we're always going to be able to compensate on the other side somehow. So when people lose, may have an injury to one eye, they'll still maybe be stimulated some way to be able to still see things on both sides, still see a full picture. Right? So it's always there to aid us in case anything happens. And then our visual cortex is at the back of the brain here, and that's where we process all the information to make sense of what we're seeing. What time is it? Go ahead. Color processing is a two-stage process, right? We got a trichromatic theory from Heimhaus, which is the retinals, red, green, and blue cones respond in varying degrees to different color stimuli. I think we only get red, green, and blue, but it's just like if you mixed all those colors up. If you're painting, you can create all types of colors, right? But it responds to varying degrees of color stimulus that we see. Then we got the opponent process theory, which are cones responses are then processed by opponent process cells, which basically we have those bipolar cells, and so they work kind of against each other and with each other to mix to make black, whites, colors, detail, sharpness. So the rods and cones work together to create a full, entire, detailed picture of what's being looked at. And we have specialized nerve cells in the brain that respond to specific features of stimulus such as shape, angle, and movement. So those are called feature detectors. These cells receive information from the ganglion cells in the retina, and they pass information to other cortical areas where teams of cells, supercell clusters, respond to more complex patterns. So that part is where we have looking at complex shapes, dimensions, depth, length of things that we're seeing. All right, parallel processing, the brain's ability to do many things at once. So we're not just looking at things and that's the only thing we're focusing on. We're doing other things as well too, right? So a visual scene is first divided into subdimensions, and perceptions are constructed by integrating separate but parallel subdimensions. Here we say, here we're looking not at just one thing, which is just the flight of the bird. When you see the bird in motion, you're also looking at the form of the bird, the shape, right? You're looking at the depth of the bird. And you're also looking at the color of the bird. So we have this process by which we don't focus on one particular thing. So we look at all things at once to form a picture, an image. Gestalt is an organized whole. How do we take bits and pieces of things and make them whole? Right? These psychologists propose principles used to organize sensations into meaningful wholes. In perception, the whole may exceed the sum of its part. So how we interpret that information particularly is more meaningful as a whole than understanding the various details of that information. So we filter incoming information and construct perception. So people tend to organize pieces of information into an organized whole or gestalt. So here we can see details of things, these circles with different arrows on them. So we don't necessarily look at a particular point in the arrow, right? We look at the circle altogether. This makes more sense. Whereas this here, if you're looking at a particular area within it, you're at a loss. And we got figure ground, the organization of the visual field into objects, figures that stand out from their surroundings. So here we could just see, what do you see here? Do you see two faces, or do you see this shape, which can look like maybe a face or a candle? Right? Do you see this, or do you see two human faces looking at each other? Maybe you see both. We focus more. And we got grouping, the perceptual tendency to organize stimuli into coherent groups, right? Proximity, if they're nearby, how we place them together, continuity, perceiving smooth, continuous patterns rather than discontinuous ones, enclosure, filling in gaps to create a complete whole objects. So when we see things that have gaps, we still fill them in our minds in order to create a whole entire picture of something, even though it may seem like there's a void. And then depth perception, the ability to see objects in 3 dimensions, although the image that strikes the retina are 2-dimensional, right? Which allows us to judge distance, which is present at least in part at birth in humans and other animals. So even as babies, we're able to perceive depth, 3-dimensional objects, how far away they are, not just how tall they are and how wide they are. So we've done some tests of early 3D perceptions. Most infants refuse to crawl across the visual cliff, even though the visual cliff has conformity in its pattern here. Right? So children, infants, still could perceive that there is a barrier, that there's something wrong. They perceive that there's a drop. Crawling, no matter when it begins, seems to increase in infants' fear or height. All right, so we need both eyes to help with perception of depth. We can't particularly do it with one eye. We got retinal disparity, which is binocular cue for perceiving depth. And by comparing images from the retina in the 2 eyes, the brain calculates distance, which they also use in 3D film. What can we do with just monocular cue, just one eye, right? Depth cues such as interposition or linear perspective available to either eye alone, which is relative height, relative side, interposition, linear perspective, lights and shadows, relative motion movement, and motion perception. All right, I think I'll end off here. Important, not the most interesting of understanding the details of how we just, take in all this information through our eyes. Any questions? The chapters get better as you go on. Because we'll start talking about personality and disorders and stuff like this. This one's a little challenging. Any questions about Blackboard or anything happening on there? Everybody's good? Okay. All right, I'll let you guys get out of here, and I'll see you on Monday.